Alright, so we're back to dependencies and layers. We're going to continue where we left off in the previous video with Z layers. So getting back to the application that we started with in the previous video with ZO dependencies, I'm going to start describing what layers are. So this new section is dedicated to Z layers. So in the previous video, we could pass a dependency at the end of the world to an effect by providing a Z layer. A Z layer is a construct that will build these dependencies for ZO and then passing on the resulting instance to the ZO effect so that the ZO effect can then use it. So I'm going to describe the API of Z layers, which is very similar to that of ZOs, and then we're going to see how Z layers are very, very useful in passing very complex dependencies in the style that we demonstrated earlier with this sort of nested dependency graph. So first of all, layers can be constructed much like regular ZOs, and they're typed like ZOs. So for instance, if I want to create a Z layer with this connection pool, I can say, let's call this connection pool layer as Z layer dot succeed. So notice that the API is very similar to that of the regular ZO, and I'm going to use connection pool dot create with 10. And this is a Z layer that provides a connection pool when invoked. And the Z layer is invoked with this provide method that you pass to a regular ZO. So this is a Z layer that has no dependencies. It doesn't fail, so it's nothing. And the end result is a connection pool. So the type arguments to a Z layer resemble those type arguments for ZOs themselves: a dependency, an exception or an error channel, and a value channel. Now, Z layers usually require some sort of dependencies to solve the dependency injection problem. And the regular way of doing dependency injection is to create some factory methods that take those dependencies as arguments, which is why you can also build Z layers out of these construction functions that take dependencies as arguments. So for instance, if you want to spin up a user database, you would call the create method, which takes a dependency argument. You can also build a Z layer, which has that dependency in the dependency channel here, through what is called, let's call this database layer, as Z layer dot from function. And you can use a function argument like user database dot create, and I'm going to use create with an underscore if you're using Scala 2, or you can also use user database dot create in Scala 3 exactly as it is because it's automatically eta expanded. What this thing does is that it automatically fetches the function arguments from create, which is the connection pool, and puts that connection pool in the type signature for the dependency of this layer. So in the end, you'll obtain a Z layer whose dependency is a connection pool. This Z layer cannot fail, so it's nothing. And finally, the value is going to be a user database. So a layer that requires some sort of dependency that is a higher layer can be built with this Z layer dot from function, which automatically takes the function arguments and puts them into the type signature of the layer. So in this style, I can build all the required services as Z layers. For instance, the database layer was built exactly as it is. We can build the email service layer as Z layer dot succeed with email service dot create. Because the email service doesn't have any requirements, and I can create a user subscription service layer as Z layer dot from function, and then I can pass the creation factory method from the user subscription. So I can say user subscription dot create, and then I'm going to use the underscore to eta expand this function. Now, the way that the ZO library automatically fetches the function arguments and places them into the dependency generic type argument of the Z layer data type is done through macros, and my laptop will probably take off at this point. All right, so after a good few seconds, we have the values defined here. So after we've built these layers, notice that every one of these layers may be dependent on another layer. So each layer describes dependencies to other layers. So in order to provide a final service with all the dependencies set, we can compose these layers. And this is where layers differ from the Zio API, because Z layers have some very interesting combinators. So for instance, if I want to combine the database layer with the connection pool layer and obtain a combined layer which doesn't require anything and creates a database, I can define a value that's called this database layer full as connection pool layer, which is the first dependency. Then I'm going to feed that into the database layer with this very interesting and then operator. And this database layer full is going to be a Z layer, which has the dependencies of the first layer and the output type of the other layer. So this one will have dependencies any, that is no required dependencies, nothing, and finally user database. So this database layer full is a combination of connection pool and database layer. Imagine stacking the database layer on top of the connection pool layer. This is called vertical composition, because you can imagine that this database layer sits on top of the connection pool layer, and you can imagine the whole group as one independent entity. So this is vertical composition, and this is the operator to use. There's also something known as horizontal composition. And horizontal composition can combine multiple layers which have some dependencies, and those dependencies will be combined as well as their returned values. So for example, I can obtain all the subscription requirements for the user subscription layer, so have email service and user database exposed by a single layer. So we have, let's say, subscription requirements layer as database layer full, and then I'm going to use this horizontal composer, which is ++, and I'm going to use the email service layer. Now with this horizontal composition, because the email service layer is a Z layer with no dependencies, it can fail, and it produces an email service. Because I'm combining the email service with the database layer, I'm combining both the dependencies from both of these layers and the values from both of these layers into one. So this is going to be a Z layer with any, it can fail, and the value exposed is going to be a user database and an email service. So this is going to be user database with email service. Now in Scala 3, we would have a union type between user database and email service. You can use either notation. So this horizontal composition will combine the dependencies of both layers and the values of both layers. Now, the horizontal composition will also combine the error channel by returning the lowest common ancestor of both. And finally, if you want to obtain a single Z layer which combines all of these together, so you can use a mix and match between all of these layers, you can say, let's call this user subscription layer as a Z layer that doesn't require anything, it cannot fail, and it will produce a user subscription. Then you can feed this subscription requirements layer into the user subscription service layer. So I can say subscription requirements layer, and then I'm going to feed that because the user database and the email service are produced as values, and I can feed that into the user subscription service layer because this is a Z layer that requires both. So we're going to say user subscription user database with email service. This will not fail, and it will produce a user subscription. Now, these expressions are quite long. I'm going to put them on separate lines. All right. So this user subscription service layer requires both of these services and produces a user subscription. The subscription requirements layer produces these two services and requires nothing. So when you feed this one into this one, you will require nothing and it will produce a user subscription. So I'm going to have subscription requirements layer feeds into user subscription service layer. So finally, this Z layer is everything that we need to provide to a program that requires a user subscription. So in the end of the run method, instead of doing provide with that user subscription creation through the regular dependency injection, I'm going to simply pass this user subscription layer. So I can safely try to compile this application and run it. I'm going to wait a little bit for the compiler to compile my code. So I have a small parentheses here. Let me remove that. Let me try run the application again. So let's see what we got. Because all these layer business is based on macros, the compilation time is probably going to be a little bit slower. So notice that the entire effect operated in the exact same style as we did at the end of the previous video. So we can compose these layers in any kind of dependency graph that we like through vertical and horizontal composition. Now, continuing best practices in the style that we did earlier with companion objects with factory methods, now that we know how to build layers, it's always a good idea to create layers in the companion objects of the services that you want to expose. And the way that I recommend to do that is to go to the companion objects of the services that you want to expose and create a factory method or even a simple value that will describe the layer of that particular service. So I would create a val in user subscription that I would call live, that this is a Z layer with the dependencies email service with user database. And this can potentially fail with a throwable, or you may want to create an infallible layer. And this will return obviously a user subscription. And I would implement that as zlayer dot from function. And I would use create and then an underscore if necessary. And I would do that for all the services that I want to expose. So I would have in the email services companion object, I would have a val called live as a Z layer that doesn't require anything, that would fail with nothing, and then this would create an email service. And I would implement that as Z layer dot succeed with create. Similarly with the user database, so I'm going to have a val called live. This is a Z layer which depends on a connection pool. This will fail with nothing, and this will return a user database, again as a Z layer dot from function with create. And finally, in the connection pool in the companion object, we're also going to create a method called, let's say, live with a bunch of connections. And this is going to be an int, and this is another Z layer. So Z layer with any. This will fail with nothing, and this will return a connection pool. And the implementation is going to be Z layer dot succeed with create number of connections. Now, this is the only implementation that's slightly different because I'm explicitly calling the create method with a number of connections, which is an int. If I did a zlayer dot from function, then I would require an int to be a dependency, and an int as dependency doesn't really make sense in this case. All right, cool. So with these Z layers in place, we can of course build them or use them and provide the Z layer composed out of all these live versions and pass that layer onto the program that we want to run. I want to show you a bit of Zio magic that will allow you to provide any sort of layer to a program that requires some dependencies, and Zio will automatically try to recreate the dependency graph from all these layers. So I'm going to define, let's call this program version 2 with provide user subscription as some sort of runnable program. And I'm going to define a runnable program version 2. Runnable program version 2. And I'm going to use program version 2, which requires some dependencies. And I'm going to call provide. And instead of building this elaborate user subscription layer myself, I'm going to pass just the required live Z layers, and Zio will take care to automatically wire all of these together. So I'm going to simply provide user subscription .live, email service .live, user database .live, and connection pool .live with, let's say, 10 fictitious connections. And notice that I've simply passed all these layers, and every one of them has different kinds of dependencies. Now, through macros, Zio will traverse the dependency graph required by the program version 2 and try to fix or try to figure out which connections to make between all these layers so that the entire dependency graph is built automatically. So in my run method, I'm actually going to call this runnable program version 2. And I'm going to simply run this application. Now, because it's a very macro-heavy program, compiling this code will take quite a bit of time, and notice that the code compiled and the application ran as before. Now, the magic thing about this is that if I miss one of these layers, let's say the user database, so I'm going to simply comment this out, the macro-based graph traversal algorithm will figure out the missing link in the graph, and the compiler will actually tell you at compile time right before the application runs which layer you're missing. So I'm going to recompile this code. And notice that even before the code can run, ZLayer tells you, please provide a layer for the following type, user database. So the missing link was found by the graph traversal algorithm in the Zio library that's based on macros by inspecting the type signatures. So regardless of which layers you're missing, Zio will always tell you what kind of layer needs to be inserted. So I'm actually going to add a small comment here. Zio will tell you if you're missing a layer. And Zio will also tell you if you have used multiple layers of the same type. So let's assume, for instance, that I am going to duplicate this user subscription because we have a lot of dependencies, and by accident, I'm simply going to use this again. Maybe this user subscription live is being fetched from elsewhere that's not immediately apparent. Let's assume that this one is being added twice. If I try recompiling this code, Zio will still tell you that you added an extra layer. Let me actually write some proper Scala syntax. And let's take a look at the compiler error that we have right now. So notice that we have ambiguous layers. I cannot decide which one to use. You have provided more than one layer for the following type, user subscription, and this is provided by these two expressions, user subscription live and user subscription live. So Zio will also tell you if you have multiple layers of the same type. Zio will also tell you the kind of dependency graph that it could build out of the layers that you've just provided. So you can add, for instance, something that looks like zlayer.debug.tree, and this is a fictitious layer that will trigger a little output when the program will be compiled. So if I try recompiling this code, let me hit Command-Shift-9 to automatically recompile. And the code compiled, and if you click on Zio dependencies, the actual file that I recompiled, notice that we have this little tree with all the layers that were added to the dependencies of this Zio, and notice that Zio has automatically figured out which layer depends on what. So this is very, very cool. So I'm going to add a small comment here and tell you the dependency graph. Or generate, it's called a mermaid link that you can view in an online tool to view this little graph in a more interactive way. It's a simple text-based representation of this graph, which is embedded in a small link, and the web API will simply decode that link, and it will show that graph representation in a more pretty way. So you can add zlayer.debug.mermaid. but this only works if you're using only tree or only mermaid. So both of these will not work in the same expression. So I'm going to comment this out, and I'm going to just keep zlayer debug mermaid, recompile this code. Let's see what we get. We need to wait a couple of seconds. And here under Zio dependencies, notice that we have a mermaid live editor link. Notice that this also prints the graph. So zlayer debug mermaid also includes the printing of the graph tree. And this graph tree is simply represented as text encoded in this really giant link. So if you click this, it will open a browser window with this link decoded and displayed in a web application. So if I copy this URL and I open it in a browser tab, notice that we have a mermaid-js. This is the web application, and the link itself already contains the graph representation of this zlayer dependency graph, and the web application will simply display this graph in a prettier way with these diagrams and with a bunch of functionalities. For example, to export an image to clipboard, maybe you want to include that in a presentation or something. Alright, so this was a bit of Zio magic with this provide API. There's also some similar magic when you want to build a layer out of some otherwise disjoint layers and have Zio do the heavy lifting of figuring out which layer clicks where. So you can define something along the lines of, let's call this magic version 2. I'm going to scroll down a bit, and I'm going to define a single value. Let's call this user subscription layer. Let's call this version 2 as zlayer.make. And you'll add a type argument, which is the final layer type that you want to expose, which is a user subscription. And you can pass any sort of arguments that will resemble layers. So I'm going to simply copy all of these, paste them here, and zlayer will, again, take the heavy lifting of figuring out which layer fits in where, so that at the final expression, we obtain a zlayer with no dependencies, can't fail, and it will return a user subscription. So this speaks to the power of the Zio library. I'm going to show you a bunch of other features that were inspired by experience and practice. One of them is called pass-through. And pass-through will allow a zlayer to take a dependency and also expose it in the so-called value channel. So I'm going to show you an example. I'm going to call this db with pool layer as user database. .live. So userdatabase.live is a zlayer that requires a connection pool and returns a user database. If you want to also expose the connection pool in the value channel here, you can also do that by saying userdatabase.live.passthrough. And this will expose a zlayer with the dependency having the connection pool. This will fail with nothing. And the value channel is going to be connection pool with the user database. So not just the database, but also the dependency which was required beforehand. So pass-through is one of these nice utilities to do that. You can also take a dependency and expose that particular value to be used in further layers. So this is called service. That is to take a dependency and expose it as a value to further layers. So you can have my, let's call this db service as zlayer.service with the type user database, for instance. So whoever requires this user database will then be able to push it forward in whatever layers require that user database after the fact. So this is the service pattern, and then we have a feature called launch, which will start an actual Zio effect, which will never finish, given the existence of the particular dependencies that the zlayer requires. So for example, I can quote-unquote start this user subscription service by saying, let's call this subscription launch as user subscription.live.launch. Now, user-subscription.live, of course, it's a zlayer requiring the presence of an email service with a user database. So this Zio will have the exact same requirements. So this is a Zio with email service with user database. This will fail with nothing because that's what the layer fails with. And the value type is going to be nothing because this 0 will never finish. And this pattern is pretty useful for the situations when your entire application is a layer. For example, a server or an infinite game loop or something that never finishes. So this user subscription in this case can simply start and just be for the duration of the application. So that was another cute feature of the ZLayer API. And a hidden feature of ZLayers is memoization. Memoization means that once a layer is instantiated, the same instance will be reused in all the layers that require it. And this memoization feature is active by default unless you modify a particular layer with the modifier fresh. So when you do fresh, this will instantiate a new version of this particular layer. Now, one last thing before we wrap up. The Zio runtime and the Zio standard library already provides a bunch of services for you. And these are clock, random, system, and console. And all of these effects will require a certain service to be able to perform it. So for example, if you want to fetch the system's current time, so get time, that is clock dot current time. And you will pass a time unit from the Java API actually. So this is a time unit dot seconds. And I'm actually going to import time unit because I don't really remember the API by heart. So time unit dot seconds. And this is an effect that is already provided by the clock service. You'll also have the possibility to generate random values. So let's say random value as random.nextInt, for instance. And this is an effect that when evaluated will produce a random integer. And this will be a Zio effect that will produce int. The service called system is very useful for getting and setting environment variables. So I'm going to say, let's call this sys variable as system.env, and you'll pass the variable name like Hadoop home or Java home or something like that, and this will return a string. So this is going to be an IO with option string, of course, if this variable has been set by the system. And finally, console is the most straightforward. The effect of printing something, so println effect as console.println. This is Zio. And the println, I've actually typed this out of Reflex, but the API is actually print line exactly as it is, with the camel case and full words. So all these services, clock, random, system, console, will be automatically instantiated by the Zio application. So whenever you include Zio app default in your application's type signature, all of these services will be included for free. Alright, so we've learned a lot. Let's take a second to recap what we've just learned. So we explored layers by looking at dependency injection first, and we found that the standard dependency injection, that is passing constructor arguments to the services that we want to instantiate, is quite clunky because it doesn't scale with the number of services that we might need in a real-life application. It becomes quite hard to debug and understand. It needs serious discipline to do well and quote-unquote correct because it's very tempting to pass these dependencies partially and have them scattered all over the place. It will almost always need to instantiate these services at the point of call of our APIs, which is the reason why, if we're not careful, calling these APIs many times can accidentally create these services many times, which is obviously inefficient, and it can also leak resources. And this is why Zio comes with an alternative, which is the dependency defined in the type signature of the Zio effect itself. And therefore, through this pattern, we only need to mark these dependencies as needed when they are needed, and not necessarily instantiate them on the spot, and only pass them once at the end of the world when we actually spin up our services. This approach has a bunch of benefits. First of all, the fact that the business logic is not cluttered anymore by the instantiation of these dependencies or by the extra constructor arguments that an undisciplined dependency injection pattern may entail. Resources will only be used once at the end of the application because the natural pattern is to simply pass these dependencies at the end of the world, therefore increasing efficiency and avoiding the resource leakage. At the same time, the logic that we're actually interested in, the business logic, is very easily testable by passing a different resource implementation, for example, a mocked or a testing one, when we need it. And with those principles in mind, we introduced the zlayers API. So zlayers can be built like regular zeros with zlayer.succeed, .fail, .attempt, and so on and so forth. So they can be built like regular zeros. Zlayers are these data structures that can be passed as dependencies to effects. You can also create a layer out of function arguments, and through some magic macros, the ZO library will automatically infer the zlayers dependencies and the values that this layer will produce. The eta expansion is only needed in Scala 2 if you are passing a function value built out of a method. You can also compose these layers in a variety of ways. The two most important ways are vertical and horizontal. Vertical composition essentially eliminates the middleman, and this will return a layer that will consume the dependencies of the first layer and produces the values of the last layer. And horizontal composition means combining the dependencies and the values of all the layers involved in the composition. Now, the Layers API also has a macro-based magic auto-wiring functionality. So all you need to do is pass some layers in the arguments to provide or to zlayer.make, and the ZO macro-based functionality will take care to infer the type dependencies of every layer and determine the dependency graph of your entire structure and figure out which layer depends on what. This is pretty magical. And this is macro-based, which means that there is a native Scala 2 and native Scala 3 macro functionality in ZO with some rich compiler errors if you are missing layers or if you duplicate layers. You can also do a pretty printed graph representation to the console or as a mermaid link in some pretty interesting diagrams. So that is everything that you need to know about ZO with zlayers. Join me in the next big lesson.